Hello guys, welcome to Network Bytes. This video will be talking about Wireshark, which is a packet capture and analyzer tool. For anyone who wants to understand networking, has to understand how the data flows in internet or in any network. So Wireshark is one such tool which helps us capture the packets over an internet or network and analyze them. So after this video, you will be understanding how to install Wireshark and how to capture packets and how to analyze the packets. So let's go ahead with the discussion. So now let me start with the installation first. For that, for the installation purpose, you have to download Wireshark. I have already downloaded it onto my local machine. You can download it from the link that is provided in the description box. So after you download it, just click on Wireshark and just proceed the same way that you do with installation of any application. So you can just choose the options, and I don't want any additional add-ons. So I'm just finishing the installation. It would take around 40 to 60 seconds. That's it. We are done with our installation. Yeah, now we have Wireshark installed. So let me try launching Wireshark. So as soon as I launch it, I see multiple options. So these are all the interfaces that are available on my machine or on my VM. So you can select the interface through which you are connected to a internet, connected to a network or to the internet. So I'm currently selecting Wi-Fi through which is my interface through which I have connected to network. So I'll just select it. I'll just double click. As soon as I select it, there will be a lot of handshake that is happening between my machine and internet. So all the packet captures you can see here. So here you can understand what are the different options provided, like file, edit, view, go, capture. So you can just explore around this, and you have multiple options like display filters and display macros, and there are multiple options. You can just go ahead uh, and get yourself hands on with that. So here, let's understand the basic features and important features. So now this is one option that is provided as a shortcut to stop the packet capture, and this is to start the packet capture. So if you have any existing packet captures going on, you can choose to save them or continue without saving. So whenever you save them, you will be having an option to save them as pcap file. So that will be present on your local machine, and you can analyze them later whenever you want to do it. So it's all about how you want to what you want to do with the data. So currently I don't want this capture to be saved. So I'll just continue without saving. So that has just started the capture. There is another way to save it. You can save it here. So when I stop it, you will find an option to save it. So you can save it from here. So there are multiple options to save it. So let's not go deep into it. Now there is one option provided to filter the traffic. So like you can filter the data. Like I have huge data that is flowing on that interface, that is from and to internet. That is I'm at a time I might be using multiple websites, so there will be huge data that will be coming here. So it will be difficult for me to find out the transmission between a particular website and my device, right? So in that case, you can choose to filter the IP from which you are sending or to which you are sending. You can select source or you can select destination IP by using IPDST, and there are options like destination host. You can just give the website name, and there are options to choose the port like TCP port. So you will find port numbers with TCP and UDP majorly because as we discussed in our OSI reference model video, port is a layer for utility. Like transport layer is one which deals with ports and sockets. So mostly you will be getting an option to choose the port number with TCP or UDP, which are majorly known as layer 4 protocols, that is transport layer protocols. So now you can just filter with any option that you want to get. Like I can choose an option to filter with protocol. So I'll see all the protocols, all the data that is using HTTP protocol. So there is nothing here because I didn't try to access any website in between. So there is no data here. So if you want to get the data that is flowing as a source 192.168.0.2, you can just do that. IP.src is equal to, I'll just do 192.168.0.2. You will see whole data which is with the source IP as 192.168.0.2. Not only that, you can choose a data based on destination, based on protocol, based on port number. So there are multiple options provided. So you can just explore around. So these are the major things. And now let's try to understand it with a real-time traffic. Now let me take an example. This is my website. Let me try to access it. I'll just go to web browser and I'll just paste it here. So as I said, like the data flow will be like from application layer to presentation layer, then session layer, then network transport layer, network layer, and data link layer and physical layer, right? So you might be knowing the flow already. If you don't know, like you can understand it from our previous video that is on OSI reference model. I'll provide the link in description box. You can just go ahead and uh, understand what exactly the layered architecture in OSI reference model. So here I'm just initiating a web traffic, that is test php.oneweb.com. So when I start it, so you have got the data here. So I'm not sure if I have enabled capture at that time. Okay, capture was not enabled. My bad. Let me start the capture first. Now let me go to website browser and let me start initiating the web data. Right, you got the traffic here. So now I'll come back and I'll just stop it for the time being, and I'll try to filter based on HTTP, and I'll just click go. So you will see a request and response. Request is a request to this particular website, and there is a associated response also, that is 200. Okay, these are all header files that are provided in HTTP. So you can see the response what it has sent. It has sent this much of data. So this is exactly how the data flows in real time and how the packet capture happens on Wireshark. And that's how you can just capture the packets and analyze them. And if you see here, there is a layered architecture that you can see for a request hypertext transfer protocol, which is a layer 7, and you will see encoding happening inside it. And because this should be a presentation layer thing, but here it is happening as part of application layer. Why? Because in real time, no model uses no real time nowhere in real time we use OSI reference model. We use TCP IP model, which has majorly 4 layers. That is application layer, presentation layer, and session layer are included to be one layer. That is application layer. So that's why you can see only one layer that has the functionalities of application layer, presentation layer, and session layer together. So along with that, you can see transmission control protocol, which is a layer 4 protocol, and you can see internet protocol, which is a layer 3 protocol, and you can see Ethernet to and frame, which are layer 2 protocols. And again, layer 2 and layer 1 are combined in TCP IP architecture reference model, TCP IP model, which will be treated as only data link layer. I mean, which will be one layer. So this is exactly how it happens. Now, along with that, let's try to understand a small concept here, along with whatever we have discussed so far. That is currently, let me cancel this whole data. Before that, here you can see a sign up option, right? So you have got a login option. So username is something which is known to everyone generally. Password is something which is to be kept secret, right? So let's try to do a small trick here. Let's try to understand a small trick. It's not that we are doing. It is happening because of some protocols. Let's understand that. Now let me go and let me remove the capture, this one. Let me stop the capture and let me initiate a new capture. Okay, I started it and I'll go back to the web page and I'll give my username as admin and password also as admin. Now you can see that the request has been done. Now you can see the packet captures here. Now I'll stop it for time being. Now let me try to get the HTTP data filter. So whenever we do that, it will be sent as a post request. This is where the request has been sent. How can we confirm that uh, this is the communication from our machine to that website? That you can just do by using a ping request. Like you can just confirm the IP of that. That is 44.228.249.3, which is IP of this test PHP oneweb.com. So that you can see it here 249.3. So this is the request that has been sent when we clicked on the login page. Now let's try opening this. So let's understand what exactly is happening here. At the end, you can see HTML from URL encoded. You can see username as admin and password as admin, right? That means this information, whichever is sent over a HTTP request, is not secured. So that's what exactly specified on any website that is of HTTP type. It is this website is not secured. So this is just a information to make sure that you browse internet securely. So whenever you see a HTTP website, be aware that there are chances that the information is visible to somebody sitting in between you and the server. Yeah, this is one thing. So let's come back to our packet capture thing and layered architecture here. So here in the whole process, it is that you can capture the packets and you can analyze it. But one thing that must be haunting you right now, right? So there are only 4 layers because there are only 4 layered architecture that we can see. We cannot see 7 layered architecture at least. That's because in real time we use TCP/IP. For that, we'll be making another video. And if you have not watched what is the OSI reference model architecture, uh, I'll be providing the video link in the description box. Please go and watch it. Thank you for watching the video.